Hello, welcome to this video. Today we're going to look at two geometry problems. So the first one is if we have a circle and a smaller circle inside of it with the same center, and this line, which is a chord of the big circle and is tangent to the smaller circle, is of length 40. Question is, what is the area of this ring around the smaller circle inside the big circle? Question, first of all, if there is a fixed area, or does it vary by the radii of the smaller and the big circle? If it does vary, then just give two examples to show that you get different areas. If it doesn't vary by the area and it's always the same, what is that area? The second question is, if you have any quadrilateral you like, you pick any point in the middle and connect this point to each center of each line segment of the quadrilateral, and then we'll mark. So this is the center of this line, this is the center of this line, and so on for the other two. And we'll mark these areas as S1, S2, S3, and S4. Question is, what is the relationship between those four areas? There might not be one, but there is one, and we'll find it. So, first of all, let's get on with the first problem. So, what we have is a circle, and inside of it a smaller circle, and a chord of the first circle, and a tangent to the second smaller circle. And the length here is 40. So with these kind of circle problems, usually you want to focus on the radii, and if you want to find the value of something, maybe try to evaluate it using the radii of the circles that you have, and then find out maybe what that area is using givens that you have. So first of all, let's mark this as the center. So we'll be able to say if this line is tangent, that means that if this is a radius of the circle, the smaller circle, this is 90 degrees. And because it's the center of the big circle, we can connect these 2 points and say that these two are the same radius of the big circle, which we'll call R. So we'll call the radius of the big circle R, and these are both big R. And we'll call the radius of the smaller circle small r. Now what we have is a line is a triangle with 2 equal sides, meaning that when we take from the point where the 2 lines with the same length meet, when we drop the perpendicular to the third one, this is also gonna turn these 2 angles equal, but that doesn't matter to us because this is also gonna make it so these 2 segments are equal. So the segment that this perpendicular line cuts this, the 2 segments that this perpendicular line cuts from this big original line are the same, meaning that both of those are half the length of what was the length of that line. Well, because that entire length is 40, we can say that this length is half of it, which is 20. And so this is the length of this area, and now the length of this segment. And now by Pythagoras, we can say that 20 squared plus r squared plus small r squared is big R squared. So we have a relationship between big R and small r. So big R squared is equal to small r squared plus 20 squared. And now let's figure out the area of what we actually want to find. So the area of the ring around the smaller circle and inside the big circle is just the area of the big circle minus the area of the smaller circle. The area of the big circle, because its radius is big R, is, so let's mark the area we're looking for. Let's mark it as A. It's pi big R squared, so that's the area of the big circle, minus the area of the small circle, which will give us the area of the ring around this. So this is going to be minus pi smaller squared, which is, if we take pi out of it like this, we get pi times big R squared minus small r squared. Now r squared, we figured out, is small r squared plus 20 squared. So this is pi times r squared plus 20 squared minus r squared. And now r smaller squared minus smaller squared, these cancel out, and we get pi times 20 squared, which is 400 pi. This was actually a problem that I had to solve on a certain exam. This is the solution, and no matter which radii you choose, as long as the length of that tangent is 40, this area will be 400 pi. The area of the ring around it. So that's the first problem done. Now let's get on with the second problem. Okay, now let's get on with the second problem. So I've drawn it back and removed the s's, so it can be clearer what we do here. So remember, this is still S1, S2, S3, S4. So what I did, at least, is also take these lines to the point of the actual quadrilateral, to its corners, and then I looked and saw that because those segments are half, I'll be able to say that this is equal to this, and then maybe this is S2 minus this, and it'll go around, and maybe we'll get a certain nice cancellation. Maybe it'll cancel out nicely. So what I did is say this area is A. Now because this area is S1, I can say this is S1 minus A. But because this is the middle point in a triangle, so let me quickly draw this. In a triangle, if you take the middle point from a corner to the opposite side, this area will be equal to this area. It's not that hard to see if we just drop a perpendicular line like this, and then this is, and then if we call this H, and then this is A and this is A, so both these areas will be AH over 2, just by the area of a triangle. So that's that covered. So we can say that if this area is A, because this is the midpoint, this area is also A. But remember that now this area is S2. So this is S2 minus A. But now we can do this on both of these. This is S1 minus A, and this is S2 minus A, again because of the midpoint. And then we can say, because this area is S3, we can say, so this area is S3 minus this, so it's minus S2 plus A. And similarly here, we get that this area, because this area is S4, we get that this area is S4 minus S1 plus A. But again, because of the midpoint, we can say that the areas of these two triangles are equal. So we get that these are equal. We can cancel out the A, which is what we hoped for. And now we get a nice equation with S1, S2, S3, S4. And if we quickly rearrange this, so we add S1 and S2 on both sides, we get S1 plus S3 is equal to S2 plus S4. So the sum of the opposite areas are the same. S1 plus S3 is equal to S2 plus S4. And so let's write the solutions to these. So this was 400 pi. This here was S1 plus S3 is equal to S2 plus S4. And finally, that's it. If you want more content like this, please subscribe to my channel. I'll be uploading more interesting problems and things like this in the future. And finally, that's it.